welcome to my YouTube channel Physics Numericals. Today in this video I will solve a numerical based on the concept work energy principle. So first of all, what is work energy principle? According to this principle, work done by net force in displacing a body is equal to change in kinetic energy of the body. So this means when a force does some work on a body, जब किसी बॉडी पे कुछ काम होता है, देन द काइनेटिक एनर्जी ऑफ द बॉडी इंक्रीजेस, उसका काइनेटिक एनर्जी इंक्रीज करता है बाय द सेम अमाउंट. इट मीन्स दैट जितना वर्क हुआ उतना काइनेटिक एनर्जी में चेंज आएगा. दैट इज वर्क डन will be equal to change in kinetic energy, kf minus ki. Here kf represents final kinetic energy and ki represents initial kinetic energy. So in other words, we can say that this principle states that work and kinetic energy are equivalent quantities. जितना work done होगा उतना change आएगा kinetic energy में. If work is done on the body is positive, its kinetic energy will increase. If the work done on the body is negative, its kinetic energy will decrease. Now this work energy principle is true for any system of particles in the presence of all types of forces, whether the forces are conservative or non-conservative. This work energy principle is equally valid. So let's see and solve the numerical. Find the average frictional force that would stop a car weighing 500 kg in a distance of 25 meter if the initial speed is 72 किलोमीटर पर आवर. यहाँ पे इस क्वेश्चन में हमको पता है कि एक कार है जिसका वेट 500 kg है. m is equal to 500 kg. Distance traveled by the car is 25 meter and initial speed of car is u is equal to 72 किलोमीटर पर आवर, जिसको हम लोग मीटर पर सेकेंड में बदल देंगे by multiplying 1000 and by dividing by 60 into 60. So the initial speed will become 20 meter per second. यहाँ पर हम लोग को पता करना है कि एवरेज फ्रिक्शनल फोर्स क्या होगा. यह कार जो मूव कर रहा है इस पर नेट फोर्स जो लग रहा है दैट इज फ्रिक्शनल फोर्स एंड दैट इज रिटार्डिंग फोर्स. इट विल हैव अ टेंडेंसी टू स्टॉप द car. So we have to find the average frictional force that would stop a car. We know from the work energy principle that the work done will be equal to the change in kinetic energy of the body. So यहाँ पर frictional force is the net force acting on the body and the distance traveled by the body is 25 meters. So we can find out the work done as equal to F into S. F is the frictional force and S is the distance, that is 25 meter, and by using this formula we can find out the work done by the frictional force on the body. Now what will be the change in kinetic energy of the body? Initially the body is having a speed u, so by using the formula half m u square we can find out the initial kinetic energy ki. But finally the car stops, so final speed of the car is 0, so kf, that is final kinetic energy, will be equal to 0. Let's see this equation. We will get F, and by multiplying F into S we will get the work done, and half mv square, where this v represents the final speed which will be equal to 0, and this u represents the initial speed, and finally we will get F equal to minus 4000 Newton. Here negative sign shows that this frictional force is the retarding force and it will result in the decrease in the kinetic energy. Finally the average frictional force will be equal to 4000 Newton. Thank you.